Okay, so in this video I'm going to cover an extension to the prior video, which is going to discuss in this video the concept of a double loop. But I'm also going to introduce some concepts of analysis that allows us to understand the running time in a little bit more detail. I'd like to mention it primarily because there are some caveats there, so it is going to be a little bit math heavy, but actually only briefly enough to describe some of the issues surrounding these cases where you write double loops. So a double loop basically includes a outer loop, such as the one I wrote before, where we're going to loop through from x is equal to 0 to a condition where x is less than 10. When it's equal to 10, it terminates, and we're going to increment by 1. And I'm also going to include an inner loop where int y equals 0, y is less than 10, and I'm going to do y plus plus. Just to kind of show this, in some ways it looks exactly the same. One of the differences, however, is I'm going to include a demonstration of the order that these things execute. So I'm going to write x. I'm also going to, in the next line, write y. I'm going to start. What you're going to see is a pattern here, hopefully, where we're going to be going through what we're going to wind up doing is we're going to go through all the values of y for each time we go through x, one value of x, and then we iterate or we increment. We're going to go through all these values of y. We're going to execute the inner loop finishes first and then increases to the next step. So we start off with 0, y is 0, x is 0, y is 1, x is 0, y is 2, etc. until x is 0, y is 9, and then x becomes 1, and it repeats the process. Now these are very useful in these cases where you have something like the screen coordinates and you're going through all the pixels on the screen. But there are some challenges mathematically to these inner and outer loops. Okay. Now the reason that there are challenges is because there's a growth factor here. So normally, and this is where we get into something what in computer science they call O notation. They're referring to sort of the growth of some function or algorithm, how the inputs relate to the outputs in a way that as the inputs increase, the running time or sometimes just the amount of steps increases in a certain way. So if we were to remember something in math, perhaps you were exposed to this concept already or you are already familiar with it, and a lack of attempt to butcher it, the concept is that there is what we call maybe a linear growth. In some cases, they would be called just a linear function or a linear a form of a line. There's different ways to put it, but the basic idea is that you have a relationship between two variables, perhaps x and y. In this case, we would, where as x changes, y changes by a certain amount. There may be an additional thing called a coefficient, or not coefficient, a constant, and that constant wouldn't change. So the real thing that changes is x and y. Now, they change by a certain amount, almost like a staircase called a slope, where if x changes by, let's say, 1, y changes by 2. This could be put in an expression, maybe 2x. And then, of course, you may have a constant 2x plus something. So the general form is mx plus b. But y is equal to mx plus b. But in this case, what we have is we have a different relationship where the amount is not constant, but rather expands proportionally as x increases. There's going to be a further increase in y. So there's actually a change. It's not a constant change. So this would produce instead a curve. So when looking at polynomials, instead of being linear, it might be quadratic. In this case, it's quadratic. So the growth is quadratic. Now, if you visualize this, you could think about the general concepts around rate of change as taking 2 points, in the case of a line, and seeing the difference, dividing out the difference between y2 minus y1 divided by x2 minus x1 as a ratio. And in general, you can think about the quadratic as a changing relationship. So instead of being constant, it changes.